In 2010, the gaming world was introduced to Blur, a racing game that fused high-speed racing with chaotic combat. Basically Mario Kart, but with realistic cars and environments. Unlike Mario Kart though, you don't just get the most powerful power-up for simply being last. As with many other games, the single-player mode was kinda repetitive, but in the multiplayer arena, players got to experience the true meaning of chaos, with up to 20 cars competing for first place. The game was well received and a sequel was planned for 2013, but was cancelled due to poor sales. Now in 2024, I attempt to make Blur 2. A fake Blur 2. First I need a car. Luckily Epic Games has graciously given us chaos vehicles, so let's add the template. I need a track. I mean, this is fine, but it has too many sharp turns. But I obviously need a road mesh. There's this thing called a spline mesh that allows us to bend the mesh's profile to follow a custom curve. If we join a bunch of these together, we have ourselves the road generator. It can be applied to many other things, not just roads, you name it, like chains, fences, the yellow divider thing that separates lanes, and so on. So, to get this mesh, I've taken a little road segment from the CC Sample project and I've cleaned it up in Blender. Now let's create a road blueprint and make it unnecessarily complicated. Okay, I'm joking. Almost. I just added a bunch of features like being able to procedurally add multiple mesh types and scale and offset each type separately, snap individual meshes to the ground. I can have multiple meshes in one actor, but what if I wanted to link meshes from two different actors of this type? Well, now I can. If I don't need any bendy objects, I can generate static meshes instead, which can be instanced. Useful for road furniture like lamps or traffic cones. All the meshes get destroyed and recreated every time I compile, and that can get slow. So I can temporarily disable the generation of meshes far away from my working area. I can also display patterns like this. There are still a few more features, but I don't want to bore you with the details. With this, I can create a test road like this. And maybe this spline will be useful later. But the handling of the car is terrible. Chaos Vehicles gives us lots of options to change. Too many with hardly any documentation. But after much fiddling, I end up with this. Alright, that's an easy fix. We just move the center of mass lower. Oops, too low. A great place for the center of mass is the center location of the four wheels. So I'll just average out the wheel locations to get the center. From here, I'll raise it up just a little bit to give the suspension some bounce as the vehicle turns. I've added points to visualize the default center of mass and also the modified center of mass. But I don't like the look of the default car. Much better. I didn't model this myself.
Ain't nobody got time for that.
Downloaded this one from the internet and I've reached each tire. The entire point of Blur is its power-up system. There are 8 power-ups, some of them offensive, some defensive, and some both. They are the barge, which creates a shockwave that damages every car in a radius around you. The bolt, which consists of 3 high-speed projectiles. The mine, which is an explosive trap that explodes when a vehicle touches it. The nitro, which grants its user a short burst of speed. The repair, which hides your turbo driving by making your vehicle good as new after you crash into a wall. The shock, which sends lightning at a leading player. Some people are just haters. The shield, which protects your car from damage. The shunt, which is a low-effort homing missile that targets the nearest vehicle ahead when fired. I've created some meshes to represent each power-up. Some of these don't look so great, but their emissive materials should hide it. First up, the bolt. This is our bolt mesh. We can join a bunch of them together to create a mega bolt, and we have our bullet. One problem though, is that this moves really fast and will pass through the target a lot of the time. Collision is detected at regular intervals by tracing a capsule, but if the capsule is not overlapping the target when the collision check happens, it passes right through the target without being detected. I could simply elongate the capsule, but that just increases the risk of detecting unwanted objects. I could also try sub-stepping, which just means that we increase the frequency of collision checks. But if you make the speed high enough, we come back to the same problem. This can also easily taunt performance if we check too often. much better solution here is to sweep a trace from the bolt's position in the previous frame to the bolt's current position, detecting any object that is in the way. This has virtually no chance of missing the target. But before we go any further, we need a way to pick up power-ups and store them on our vehicle. So we need a power-up deck, a closed spline that will store a maximum of 3 power-ups, or 10, or however many we'd like. Remove power-ups after they are used or dropped, and cycle through the available power-ups in the deck. We still have no way to acquire the power-up, so for the pickup actor, I'll use the power-up meshes I made earlier. For the shunt, which is home in, we simply make it accelerate to the target with a clamped speed. But what if the road were to be very windy with a lot of twists and turns before the target? The missile would literally just fly straight to the target without following the road. We obviously want it to always stay within the bounds of the road, but I'll fix that later. We need some HP, otherwise there is no point of having a repair power-up, is there? So I have a spline, like the one we used for the power-up deck, with 5 green bars in it. When damage is taken, bars get removed and the remaining get redder. When the health gets to 0, the car gets wrecked and is reset. I've added these bars to the HUD also, along with the rear mirror, which is empty for now, but there are more important things to do first. For the shield, I'll use a glass dome for now. I'm also going to save the shock power up for later. But I can't race against myself. Well, I could have some kind of time trial, but what will be the point of having power-ups? So, I've created some AI. I built the road with a spline, so that is being used here as the path for the AI. It repeatedly gets a point on the spline ahead of its position and moves to it. Let's call this the target point. This will be the target tangent and this the target normal. But this is far from optimal, because the AI has no awareness to follow the racing line. What is the racing line, you ask? This is the straightest path you can take when rounding a curve. The path that allows the car to maintain as much of its speed as possible when turning. So it has the least chance to skid, minimal speed losses and a fast lap time. To achieve this, I made the target point the closest point on the line along the width of the road. This stops the AI from making unnecessary turns towards the center, so it always tries to take the shortest path to the target normal. Let's see if I can beat the AI. I got a little bit of a head start, and I lost it. Let's see how it does on the next turn. Enters a turn a little bit slower than I did, hogs the inner corner, and exits with a faster speed. The AI wins the first round. Let's try that again. I cheated just a little bit with this one by blocking the AI. It tries to maneuver when there is another vehicle in front of it, and that slows it down just a little bit. Alright, I'll take the win. Now we can go back to the shunt and apply a similar algorithm so that it follows the road. And it works. For the nitro, I just added some impulse to push it forward and animated the field of view to give it that extra sense of speed. Next, audio. So I thought to myself, what is the best place to get a great V8 engine sound? If you said directly from a car, you're wrong. The best place is objectively from Andy the Great's engine simulator. Take a listen. It would be really great to implement the engine simulator into the game to generate sounds procedurally, but that would be an unnecessary cost on the CPU's resources. So I just recorded a few RPMs that I've blended together based on the engine's RPM in Unreal. I've also added some skid sounds and effects. No racing game is complete without drifting, so I added a simple handbrake drift by reducing the rear wheel friction. I'm sure that's not the correct way to implement a drift mechanic, but it will have to do. Next, some vehicle deformation. Epic Games showcased the vehicle deformation system with a CT sample project, which worked great, but the setup is tedious. It needs a rigged vehicle with a pretty complex skeleton, so I created my own that is used with plain static meshes instead. The vertices from the static meshes are copied to procedural meshes that are modified at runtime. When a collision happens, we get the hit location and get all the vertices in a certain radius and move them with a quadratic fall-off. How? We have to loop through each of the 700,000 vertices of the mesh and check if its distance from the impact point is less than the impact radius. The vertex closest to the impact point gets moved the greatest distance. We also change the vertex colors so we can blend in the damaged material using the vertex colors as a mask. But this doesn't look like a very convincing car crash, so I separated the parts of the vehicle like the bonnet, bumper, boot, doors and so on, and also made the glass breakable. I also added physics constraints to the bonnet hinges so that they swing when damaged. We detach the body parts once they have passed some damage threshold. We also move and wobble the tires as hits happen, otherwise it will look weird. So, we're doing a lot of looping and calculating a bunch of stuff for each iteration. If that sounds like a lot, it is. More accurately, I'm looping through a version of the mesh that has been simplified with Nanite. If you've never heard of Nanite, it is a built-in tool developed for Unreal Engine 5 that dynamically reduces the poly count for high poly meshes, the further away they are from the camera. So only the visible geometry gets rendered. That's great, but I don't need most of that. What I need is the decimated fallback mesh it generates. It is this fallback mesh that I copy to the procedural mesh, loop through and deform. Also, having separate meshes for different body parts means we only have to loop through the vertices of the affected meshes. So, we're able to bring it all the way down to 47,000 vertices. Unsurprisingly, we get a few artifacts due to the aggressive decimation. But this is not necessarily a bad thing, because the car is damaged after all. We initially only display the clean static mesh and switch the visibility to the decimated procedural mesh after the body part gets hit. But 47,000 vertices, assuming we deform the entire body at once, still sounds like a lot to loop through each time we deform the mesh. So I used the parallel for, which is a multi-threaded for loop to move the vertices. That just splits the deformation math to separate threads for better CPU utilization and ultimately speed. For collision, we can't just use the mesh vertices as is because we don't need the interior vertices. So I wrote a script to wrap a low poly enclosed mesh around the dense mesh, similar to how the shrink wrap modifier works in Blender. The low poly proxy ends up being somewhere around 200 vertices on average, and we also move these vertices every collision along with the main. I also generated a better fitting shield mesh for the car using this wrapping technique. Here's a test for a few different frame times. Nothing too scientific, but if we see too much of a spike on the graph, we have
bad product.
Vehicle as a single static mesh, so this is not deformable and all of my custom code is disabled. So just basically a plain chaos vehicle with a custom mesh. No frame spike at all as expected. Vehicle as a single procedural mesh with 700,000 vertices, deformable and not simplified. Significant frame spike. Vehicle with different procedural meshes for each body part, fully deformable and each part simplified. Acceptable frame spike. Back to the lightning power. I made this lightning VFX, which is pretty much taken from this tutorial by Enrique Ventura. We have a bunch of lightning beams that shoot out of this orb like force lightning. If you enter into the cylindrical zone, you get zapped. If you stay too close to the zone, you also get zapped, but less severely. Love to see the glass shattering and the body parts flying around after a hit. I created this track with a suspended road and a bunch of trees and cliffs around, and yeah, it looks like shit. So I had the brilliant idea to just copy stuff from the Electric Dreams demo map and the Hillside sample project. As a matter of fact, I'm just going to drag and drop these into my level. Haters might say this is fake. I've added roads using my patented road spline blueprint. Some water. I've also added in some vistas from the CT sample project. I've added a minimap and I mapped the road to it, but it feels a little flat and uninteresting. So I've added some perspective so that the map bends forward to show more of the road as our speed increases. So we are now able to move the texture with a perspective effect to give the illusion of 3D. Got the material setup from Alex Engelman on ArtStation. I've also finished up the rear mirror by simply capturing behind the vehicle to ruin the target.
That thing does not obey the laws of physics at all.
Finally, let's test this thing out.